So I've been teaching the Introduction to Applied Maths course for about 3 years now, and just sort of with experience you learn there are certain things that students do that really annoy you. And so one of the things that has been annoying me recently is how the students actually sort of set up their homework. So there's the actual factual content of getting the right answer, but there's how do you present it to make sure that it's sort of clear and coherent. And you can repeat yourself till you're blue in the face in the lectures, trying to say what's the good practice. You can write it in all the homework scripts, and it never seems to make any difference. So I got sufficiently annoyed with this. I thought, how am I going to change it? How am I going to fix it? How am I going to really emphasise to people the importance of getting this right and correct? And so that's where the idea of the sort of Lego came in, as to try and sort of get something happening which wasn't directly maths based. So I could never get distracted by having to teach the factual maths content, but could actually do skills instead. So that's where that part of it came from. And then sort of the other aspect was to introduce clickers during the lectures. And again, that comes from the same sort of place of being able to give more immediate feedback. So rather than relying on sort of maybe giving feedback in the lecture a week after the question's been submitted or writing it in solutions, what I can do is students try a question, I instantly give feedback. Okay, and so it's much harder for them to then say, oh, this doesn't apply to me, or to sort of not have done it, to still be confused. We can really sort of emphasise what they need, and hopefully that leads to better learning outcomes. Right, so I've completely redesigned how the course is structured compared to previously. So what now happens is that for students' homework, they are required to read a chapter of the textbook or the notes that I provide in advance of the lectures, so that they're prepared to answer lots of clicker questions during the lectures. But that means that sort of having got rid of the homework aspect, we don't need the workshops where they also used to work through the homework, and so we have sort of set up this Lego workshop in place of the traditional homework workshops. And so that's perhaps the most radically different thing that we're doing. And so what's happened with these Lego workshops is it's a sort of rotation-based learning concept. So students come in teams, and they come 3 times, and they do a different thing each time. So the first time what they'll do is they'll come along and they get a box of Lego, and they have to just build a model that they choose. And so, for example, you might build a rocket ship. And this one has sort of lovely flappy bits, and it can take off, and you can play with it. It's great fun. Okay, so hopefully students are wonderfully motivated to come and actually engage with this. And then the second part of that session, what they have to do is write instructions for how to build this. But I'm mean, right? I tell them they are not allowed to draw any diagrams when they write instructions for this. And that is really awful, because then, in the second session, these instructions get given to another team, and they have to try and rebuild it. And rebuilding it never goes so well. And that is kind of the point. So what we're trying to do is simulate, when you design something, this is the process of how do you write your homework. The rebuilding it is more the process of the lecturer trying to mark homework, trying to understand what a student has written. And I'm always there scratching my head thinking, well, what's going on? They haven't really explained things well enough. Well, now, as they follow the instructions, they go, I don't understand this bit. How does it work? And they realise that the technical writing skill is really tricky. And so you can see on the screen behind me that we have a photo of what people tried to make when they followed the instructions to this original model. And you'll see that it's quite different. So, for example, if we look, so we can take this up here. Excellent. So, if you look, this bottom bit here, this is completely different. There's lots of open structure here. And so there are aspects of this rocket that have come out very different from how the designers intended. So there's no way that anybody can really fool themselves to say that it all worked as it was supposed to, because there is a very definite picture contrast of it is not the same. Whereas in maths, everything can be perfect. You can get a right answer, get it absolutely perfect. So they should be striving to do this. And so this really emphasises the difficulties in technical writing. And so then in the third part of the session, the third session, the original team comes back to their model that they designed, and they're allowed to write new instructions. They get feedback from the previous team, they try and build it again themselves. It's been sufficiently long, they've forgotten what they did, they get it wrong as well. So it very much simulates the sort of self-reflective peer feedback sort of process that we want them to learn, but just in a non-mathematical way. Okay, so that sort of then has seemed to be very positive. Students have been really engaged with getting involved in it, and they say at the end that they are certainly taking on board the message. And it seems to have propagated through to the sort of few bits of homework that I have marked where they're getting much more of the technical aspects right. They are demonstrating more of their knowledge by writing things correctly, and so I can give more credit for it in homeworks and exams, etc. So the Lego aspect has enhanced engagement hugely because it's quite fun, or it starts off quite fun. The second session where you're trying to work out how on earth to build somebody else's instructions is actually really hard. And so there's a brief bit in the middle, but in general, it's great fun. So people have been more engaged, and as it propagates through to their homeworks. The clicker aspect also, people are really engaged. They rush in to get the clickers. They're disappointed if the things haven't turned up for some technical reason. And they're actively doing the questions. We're getting immediate feedback. They're learning sort of immediately what they should be doing. And if you're carefully structure the questions so that when you're doing multiple choice questions, you can have some of the common problems. And then you can pick out as you go through, well, if you got this answer, you probably did this wrong. And that is really helpful immediate feedback for sort of picking out those common errors and correcting them. And so that was really apparent in some of the exams this year where there were much better performances than there have been previously. There are always changes to make. There are always things that don't go quite right. So one of the things I'm changing about Lego this year is that I'm going to put the questionnaire that I've previously asked students online so that they have access to it rather than forgetting their sheets and things like that. That's a fairly simple one. But the clickers I'm still learning how to use properly. So the clickers completely change the dynamics of the lecture and the pacing of the lecture because you have to be much slower when you ask the question to give students time to work things out. And somehow, you've still got to fit in all the same content that you had to fit in before. So it's a question of balancing what content you go in there, how much you can go over questions if they don't get the right answers, and so on. So I'm still trying to get the balance of that right. So that I think is the main goal for this year, is to improve that. Because again, in the exams there were a couple of features where I maybe didn't have as much time in the lecture to go over, and it was very apparent that students didn't understand that bit as well. But they need to, so I need to get the balance right. And then the one last bit which I haven't really talked about at all in the rest of this was an extra bit of the coursework that I've added in for the module is to be doing some computer programming, and I just made it far too hard this year because programming is fine when you know what the answer is and what the particular functions you're supposed to use are. If you don't know, it can take forever, and I was getting reams and reams of paper from students, which I really didn't want. I made it far too hard for them. So we'll simplify things and with more guidance, sort of an extra workshop to work things through.